Welcome to the Deep Dive. This is where we take a whole load of information, really get into it, and pull out the key insights so you're instantly up to speed.
Ready to go deep.
Today, we are focusing on something that's, well, it's everywhere, absolutely fundamental to our lives, but we barely notice it. Doors and windows.
Yeah. Completely ubiquitous.
Think about it, right? Every single building you go into, every room, every view you look at, it's all accessed or framed by these things we just take for granted. But what if they're actually incredibly complex? Really thoughtfully designed, and way more important than we ever stop to think.
Oh, absolutely. We push them, slide them, look through them. Barely a second thought. But their design, their function, it's foundational to how buildings work, how spaces feel.
How they operate efficiently, too.
Exactly. They're sort of the silent workhorses defining the edges of our built world.
Precisely. So for this deep dive, we're not just, skimming the surface. We've got some really detailed architectural and construction resources here.
It's technical stuff.
Yeah, the nitty-gritty. And our mission today is to basically transform how you see these everyday things.
Yeah.
We're going to unpack the critical thinking behind them, look at all the different types, the intricate parts.
All the bits and pieces that make them essential. Not just useful, but essential for comfort, safety, well-being.
And this isn't just for the architects and builders listening, right?
Oh, definitely not. This is about appreciating the kind of silent engineering that's literally all around us every day.
Right. Getting a new perspective on the spaces you live and work in. Understanding the why behind it all. So as you go about your day, maybe think, how does that door affect my comfort, my security? What about the building's energy use?
And even, like you said, the emotional vibe of a place. It's subtle, but it's there.
It really is. So we're going to peel back those layers. Okay, let's dive in.
Let's do it.
So we start with the foundational role of doors and windows. Because honestly, there's so much more than just holes punched in a wall. Their importance is, well, it's multifaceted.
Absolutely. I mean, the most basic function, obviously, is access. Getting in from outside, moving between rooms inside.
The obvious starting point.
But even that isn't just a simple void. These are design pathways. They're planned, integrated right into the fabric of the building. They control flow. They separate environments.
They control what comes in and out, physically and environmentally.
Precisely.
And that planning starts way, way before you see a finished door or window, doesn't it? We're talking about needing carefully planned, rough openings in the walls first.
The rough opening. Yes. It sounds basic, but it's critical. It's not just a gap. It's the perfectly sized structural space left in the wall framing before the actual door or window frame goes in.
So it has to be bigger than the final door or window.
Exactly. It has to be dimensioned just right to accommodate the finished frame, plus space for shims. Those little wedges you use to get everything perfectly level and plumb, and also room for insulation around the frame to seal out drafts.
Get that wrong, and disaster.
Well, maybe not disaster, but definitely problems. Headaches, delays, costly fixes. If the rough opening is too small, you're cutting structure, too big, and you're struggling to fill gaps properly. It's that unseen precision that really dictates the final quality and performance.
Okay, so the rough opening is step one. And directly above that opening, holding everything up, is the lintel.
The lintel, yes, another unsung hero. It's that horizontal support beam, usually steel or reinforced concrete or even heavy timber, right across the top of the opening.
Its job is just to carry the weight from above.
That's its primary, absolutely critical role. It bears the load of the wall system, bricks, blocks, framing, whatever is directly above that door or window. Without a properly sized lintel, that wall could sag, crack.
Or worse.
Or worse, yeah. Collapse into the opening. So its size is engineered based on the width of the opening and the weight it needs to support. A small window needs a much smaller lintel than, say, a wide garage door opening.
Makes sense. It's all about structural integrity.
Keeping the building solid and safe over time.
So clearly, these aren't just functional necessities. They're deeply structural. But their impact goes way beyond just holding up walls, right?
Yeah.
From the moment you look at a building's exterior, doors and windows are shaping how you perceive it. They're compositional elements.
That's exactly right. This is where the engineering meets the art. They are hugely important compositional elements on the facade. They dictate the visual appeal, the character. Think about the rhythm they create across a wall surface.
You mean how their placement kind of punctuates or divides the wall, like visual beats?
Precisely. It's like a visual language. Their arrangement impacts the building's massing, how solid or void it feels, lots of big windows. Feels light, maybe open.
Few small windows. Feels
Okay.
heavy, solid, maybe more private or imposing.
Exactly. And it affects the visual weight, too. Does it look grounded and heavy or light and airy? And the scale.
Scale how big it feels compared to you.
Yeah. A pattern of small, deep-set windows on a huge building can make it feel grand, maybe historic, but potentially overwhelming. Larger windows might make it feel more human-scaled, approachable.
And what about articulation? That sounds quite technical.
It just means how the different parts of the building are expressed, how they connect visually, how the facade tells its story. Think about a symmetrical layout of windows, very formal, traditional, balanced.
Like on a Georgian house or something.
Right. It feels ordered, maybe a bit stately, but then you could have large, irregularly placed windows, like on a modern art gallery. That conveys something totally different: dynamism, maybe asymmetry, openness.
So they're not just openings, they're design choices, communicating style, purpose, even mood.
Absolutely. They're telling you about the building before you even step inside.
Okay, let's dive deeper specifically into doors now. Their functions, their forms, they're really tailored for different roles, aren't they? Starting with exterior doors, the first line of defense.
Yeah, exterior doors have some heavy lifting to do. First and foremost, weather-tight seals when closed. This is non-negotiable.
Meaning keeping out wind, rain, snow.
All of it. And extreme temperatures, too. A poor seal means drafts, potential water damage inside, uncomfortable temperature swings, and higher energy bills. It's the main barrier between your controlled indoor space and the wild outdoors.
So it's comfort, protection, and efficiency all tied up in that seal.
Exactly. And that ties into the second point: thermal insulation. An exterior door needs to maintain roughly the same thermal insulation value, or R value, as the walls it's penetrating.
Like not creating a weak spot in the building's thermal envelope.
Precisely. Think of your walls as an insulated blanket. A poorly insulated door is like a big hole in that blanket. It becomes a thermal bridge.
Letting heat pour out in winter.
And pour in during summer. It makes your heating and cooling systems work much harder. You can have the best insulated walls, but if your door is leaking energy, you're losing comfort and money.
Right. Okay, so that's the exterior battlefront. What about interior doors? Different priorities there.
Completely different. Inside, it's much more about crafting private functional zones within the building. Primarily visual privacy.
Closing off bedrooms, bathrooms, offices.
Exactly. Creating those necessary secluded areas. Defining different functions within a floor plan. It's fundamental to how we use multi-room spaces.
And not just visual privacy, but acoustical privacy too. Keeping noise contained.
Critically important and often overlooked until it's bad. Interior doors play a huge role in reducing noise transfer between rooms. Think about a home office needing quiet, or a bedroom.
Or apartments next to each other.
Absolutely. In homes, offices, schools, hotels, good acoustical separation is vital for concentration, rest, basic comfort, creating quiet zones.
So those are the specific needs. But then there are considerations that applies to all doors, inside or out, like just being easy to operate. Seems obvious, but...
It's crucial, and it goes beyond convenience. It's about accessibility. Every door needs to be operable by everyone, regardless of physical ability. Someone using a wheelchair, pushing a stroller, maybe with arthritis.
They need to be able to open and close it without a struggle.
Exactly. It ensures easy navigation and, frankly, dignity. A difficult door is a barrier.
And durability. A door at a busy train station versus a bedroom closet door, they need different levels of toughness.
Immense difference. Durability has to match the anticipated frequency of use. High-traffic commercial doors need heavy-duty construction, robust materials, strong hinges, solid cores to withstand constant use, impacts, you name it.
Thousands of cycles a day sometimes.
Easily. Whereas a residential closet door, maybe opened once or twice a day, can use lighter materials, simpler hardware. It's about selecting the right spec for the job so it lasts.
Then security provisions, more than just the lock.
Oh, yeah. It's a whole system. The lock set itself, yes, deadbolt, smart lock, whatever, but also the strength of the door frame and the door slab material. A solid core door resists forced entry much better than a hollow core one.
Which you could probably punch through relatively easily.
Unfortunately, yes. So security is about the lock, the door, the frame, all working together as a barrier.
And sometimes doors do more than just open and close. They can offer light, ventilation, views, blurring the lines with windows.
That's a great point. Think about French doors. Sliding glass patio doors, doors with glass panels, what architects call lights.
Lights.
Yes, lights. Individual panes of glass in a door. These doors bring in natural light, connect indoor and outdoor spaces visually, make rooms feel bigger. Screen doors add ventilation. They become multifunctional.
And finally, a really critical one, especially in public or multifamily buildings. Fire resistance requirements from building codes.
Absolutely non-negotiable. Certain doors, like those in stairwells or corridors used for escape routes, must meet specific fire ratings, like 20-minute, 60-minute, 90-minute ratings.
Meaning they can resist fire for that long.
Exactly. They're built with fire-resistant cores and materials, often have self-closing mechanisms, and special seals that expand in heat, called intumescent seals, to block smoke. Their job is to contain the fire, slow its spread, and critically, give people time to escape safely.
Life-saving features, basically.
Absolutely. Rigorously tested and required by law.
Okay, fascinating. Now let's get into the anatomy of a door. Components, operations. First, a point of confusion. Door saddle versus door threshold. Same thing.
Often used interchangeably, but technically there's a difference. A saddle is usually just a strip, maybe wood or stone or metal, covering the joint between two different floor materials at the doorway. It's primarily a transition piece.
So bridging the flooring gap.
Right. A threshold is the full component at the bottom of the doorway itself. It's usually integrated with the door frame and is specifically designed to create a seal, especially on exterior doors. It works with the weather stripping.
So the threshold is more about the seal and weather protection.
Precisely. It often has a profile designed to shed water and create that tight barrier against drafts and moisture. It's a performance component. A saddle could be part of a threshold assembly, but the threshold is the whole functional piece at the bottom.
I got it. Threshold, ceiling, saddle, floor transition. Okay, clarified. Now, how doors move. Operations. Most common first. Swinging doors.
The absolute standard. Operates on hinges, swings in or out. Needs clear floor space for the swing. You see them everywhere, interior, exterior. Simple, reliable, versatile.
Then bypass sliding doors. Often closets.
Yeah, closets are prime examples, or sometimes room dividers. Two or more panels sliding horizontally on parallel tracks, one passing in front of the other. Big advantage. Save space. No swing arc needed. Mostly interior, but sometimes exterior patio doors use this principle too.
What about surface sliding doors? How are they different?
Usually a single panel sliding along a track mounted on the surface of the wall next to the opening. Think barn doors, that kind of thing. It doesn't overlap another panel, it just slides clear of the opening along the wall. Another space saver, especially if you can't build a pocket door into the wall. Interior and exterior use is possible.
And folding doors, like an accordion.
Exactly like an accordion or bifold action. Multiple panels hinge together that fold up against each other as they open. Great for wider openings, like connecting a living room to a patio, or as flexible room dividers. Very adaptable for creating large open spaces quickly, again, interior or exterior.
And the unique one, revolving doors. Almost like a machine.
They really are a system, usually 3 or 4 leaves or wings rotating around a central vertical pivot, all housed within a cylindrical vestibule or enclosure.
Where do you typically see these?
Large commercial and institutional buildings, airports, big hotels, major office towers, hospitals, places with high foot traffic.
And their benefits go way beyond just letting people through, right? They seem highly engineered.
Absolutely. Their key advantage is the continuous weather seal. Because there's always a wind sealing against the enclosure, they drastically reduce air infiltration, those big drafts you get with swinging doors.
The stack effect.
Exactly. They minimize that, which means significantly less heating and cooling loss. Huge energy savings in a busy building. Plus, they handle high traffic volumes incredibly efficiently, up to 2,000 people per hour. They manage flow and climate control brilliantly.
But a true engineering solution. Okay, so that's how they move. Now, door types based on materials and design. First up, hollow metal doors. Sounds industrial.
They often are, though you see them in commercial settings too. It's a sheet metal skin, usually steel, over a frame. Inside that frame, there's often a core material, could be insulation, like polystyrene or polyurethane foam, or a cardboard honeycomb structure for rigidity, or minerals for fire resistance.
What are their main advantages?
Durability, security, and fire resistance are top of the list. They can take a beating, are hard to break into, and they achieve high fire ratings. So ideal for exterior doors on commercial buildings, utility rooms, stairwells, anywhere toughness is key.
Then wood flush doors. These are the simple flat ones.
Yes, totally flat surface. Usually a wood frame with veneer faces, thin sheets of wood, or sometimes laminate glued on either side. Very versatile because you can paint or stain them easily to match any decor. Super common for interior use, offering a clean, often modern look. Can be solid core for better sound insulation and feel, or hollow core, which is lighter and cheaper.
Contrasting with those are wood rail and style doors,
Yeah.
the traditional paneled look.
That's the one. Built using vertical pieces called stiles and horizontal pieces called rails. These form a frame, and the spaces within that frame are filled with panels, solid wood, glass, louvers, whatever the design calls for.
Gives you lots of design options.
Tons. Classic raised panels, flat shaker-style panels, doors with multiple glass lights. It's a very traditional construction method, allows for great aesthetic variety, often gives a sense of craftsmanship.
Next, glass doors. Obviously about light and views. You mentioned frames versus frameless.
Right. Frameless glass doors are almost entirely glass, held by minimal hardware at the top and bottom, sometimes patch fittings. Maximum transparency, very sleek, modern look. Think high-end office entrances or shower doors.
And framed.
Framed glass doors have the glass panel set within a more substantial frame. Could be wood, aluminum, steel, vinyl. Provides more structure, maybe better sealing. Very common for storefronts, office partitions, patio doors, French doors. They still prioritize light and visual connection.
And let's revisit revolving doors, now thinking of them as a specific type beyond just how they operate.
Good idea. Because their design is so unique and their purpose so specific, they really function as a distinct category. They are a complete entrance system designed specifically for high traffic and environmental control. They combine access, security, and that continuous weather seal into one integrated unit. They solve a specific set of problems exceptionally well.
Okay, now the hardware. The bits and pieces that make the door actually work, you listed a whole bunch. Lock sets, hinges, closers, panic hardware, push-pull bars, kick plates, stops, thresholds, weather stripping, tracks. It's a lot.
It is, and every single piece plays a role, from the obvious lock to the subtle bumper. Let's break down some key ones. Lock sets first.
What exactly is in a lock set, more than just the keyhole?
Oh, much more. It's the entire manufactured assembly. It includes the knobs or levers you use, the plates behind them, sometimes decorative, called a rose or a scutcheon, and the internal latching and locking mechanism itself.
And there are different types you mentioned.
Yeah, major types for different functions. Passive sets just latch, no lock for closets or hallways. Privacy sets have a simple lock like a push button or thumb turn for bathrooms or bedrooms. Entry sets are keyed for security on exterior doors. And dummy sets are just non-functional handles or knobs, often used on the inactive leaf of a pair of doors. The whole assembly works together.
Makes sense. Okay, hinges, fundamental.
The absolute pivot point, literally. The most common are butt hinges. Two plates or leaves joined by a pin. One leaf attaches to the door edge, the other to the door jamb, the frame.
And you mentioned different types of butt hinges based on installation. Full mortise, half mortise.
Right, and this detail actually tells you something about the quality or style. Full mortise is the cleanest look. Both hinge leaves are recessed into matching cutouts, mortises, in the door edge and the jamb. So when the door is closed, only the barrel of the hinge, the knuckle, is visible. Takes more skill to install perfectly.
More high-end, maybe.
Often, yeah. Half mortise means one leaf is mortised, usually into the door edge, and the other is surface mounted onto the frame. Half surface is the reverse one leaf mortised into the frame, the other surface mounted on the face of the door.
And full surface.
Both leaves are mounted right on the surface, no mortising needed. Easiest to install, often used for utilitarian doors or retrofits where you don't want to cut into existing frames. The hardware is fully visible, so the type reflects aesthetics, installation ease, and sometimes structural needs.
Incredible detail in just a hinge. What about door closers? Those hydraulic arms you see at the top of doors.
Crucial devices, especially in commercial or public buildings. There are hydraulic or pneumatic mechanisms that automatically close a door after it's opened, controlling the speed so it closes quickly but quietly without slamming.
Why are they so important?
Multiple reasons. Safety. They ensure fire doors latch properly. Accessibility. They help people who might struggle to close a heavy door manually. Climate control. They keep conditioned air in and unconditioned air out. And durability. They reduce the stress on the door, frame, and hardware by preventing slamming. Saves wear and tear, reduces noise.
Panic hardware next. That push bar for emergency exits.
Exactly. Designed for quick, easy, unencumbered exit in an emergency. You just push the bar and the door opens, even if it's locked from the outside. No need to turn a knob or fumble with a lock when every second counts. Mandatory in many public assembly spaces for life safety.
Then the simpler stuff. Push and pull bars, push and kick plates.
Simple but functional. Push-pull bars are just sturdy handles for ease of opening, often on doors without latches or where traffic flows mainly one way. Push plates are metal or plastic panels placed where people push the door open, protecting the door finish from dirt and wear.
And kick plates at the bottom.
Same idea, but protecting the bottom of the door from kicks, scuffs, carts, cleaning equipment really extends the life and look of a high-traffic door. Think restaurant kitchen doors.
Door stops, holders, bumpers, preventing damage.
Yep. Stops prevent the door swinging too far and hitting the wall. Holders keep the door open when needed. Bumpers are little rubber or plastic pads to cushion the closing and prevent noise or damage. Small details, big impact on maintenance and noise.
Weather stripping. Tiny detail, huge energy impact.
Massive impact. It's strips of material, metal, felt, vinyl, foam, brush seals fitted into the gap between the door and its frame, and often at the threshold.
What's its job?
To create a seal. Block drafts, stop windblown rain, keep out dust, insects, essential for comfort, indoor air quality, and crucially, energy efficiency by reducing air leakage.
How's it installed?
Can be fastened to the door edge, the door face, or the frame and threshold. Key things are that it needs to be durable, non-corrosive, and replaceable, because it does wear out over time from the compression and friction.
If you feel a draft, check your weather stripping.
Good rule of thumb.
And thresholds, again, linking back as hardware.
Yes, because they are often supplied as part of the door hardware package. They provide that smooth transition, eliminate trip hazards, and, crucially, provide the solid surface for the bottom weather stripping to seal against. Essential for a complete seal, especially on exterior doors.
All right, a comprehensive look at doors. Now let's shift to windows. Primary roles. Light, view, ventilation. Like doors, they're an assembly of parts, right?
Absolutely. You've got the glass itself, the glazing or the light, the frame holding it all together, the sash, which is the part that actually holds the glass and often moves, and then the hardware locks, handles, cranks, balances for sliding sashes. It all works together.
And like doors, different ways they operate. Simplest first, fixed windows.
It's non-operable, purely for light and view, no ventilation, often used for large picture windows or in areas where airflow isn't needed or wanted. Maximum glass area.
Casement windows. The ones with cranks.
Usually, yes. Hinged at the side, swing outward like a small door. Great for ventilation because the whole sash opens, catching breezes. Can provide a very tight seal when closed because the sash compresses against the frame.
Awning and hopper windows. Similar but different hinges.
Right. Awning windows are hinged at the top, swing outward. Creates that awning effect, so you can often leave them open for ventilation even in light rain.
Hoppers are the opposite.
Hinged at the bottom, swing inward, often used in basements or sometimes high up on a wall for secure ventilation.
Sliding windows. Pretty straightforward.
Generally, yes. One or more sashes slide horizontally along tracks. Good for wide openings or where you don't want a window swinging in or out. Simple operation.
Double hung. The classic up and down sliding sashes.
Very common, especially residentially. Two sashes, both can slide vertically past each other, so you can open the top, the bottom, or both partway. Offers great control over ventilation, let hot air out the top, draw cool air in the bottom.
Jalousie windows, the slatting glass ones.
Yeah, those parallel strips of glass, like horizontal blinds that pivot open together with a crank. Excellent ventilation, letting lots of air through while offering some rain protection and privacy. More common in older homes or warmer climates, generally not very energy efficient due to the many joints.
And finally, pivoting windows.
These rotate around a central pivot point, either horizontal or vertical, allows for varied ventilation options depending on how you angle it. A big plus is that you can often rotate them significantly, making it easy to clean both sides of the glass from inside, great for upper floors or large windows.
Okay, that covers operations. Now, window materials. A balancing act of cost, efficiency, looks. Aluminum first.
Aluminum is popular. Relatively low cost, lightweight, strong, doesn't rust, allows for thin frames, maximizing glass area. But
the big but is heat transfer.
Exactly. Aluminum is a fantastic conductor of heat. By itself, it lets heat flow right through the frame, making it inefficient thermally. It loses heat in winter, gains heat in summer.
So they need that thermal break.
Absolutely essential for decent performance. It's a strip of less conductive material, usually a plastic or synthetic rubber, integrated right into the frame extrusion. It interrupts that direct path for heat flow. Without it, aluminum windows can be very inefficient and prone to condensation on the inside frame in cold weather.
And finishes. They come in different colors.
Oh, yeah. Common finishes are anodized, an electrochemical process that creates a hard, durable oxide layer, baked enamel paint, or high-performance fluoropolymer resin coatings like Kynar. Very durable, long-lasting finishes.
Okay, how about steel windows? They feel different. Stronger.
Definitely stronger and more rigid than aluminum. They're made from hot-rolled or cold-rolled steel sections. Because steel is so strong, the frame and sash sections can be much thinner than aluminum.
Which means
narrower sight lines, less frame, more glass. You can fit larger panes of glass, lights, into a given opening compared to aluminum. Creates a very elegant, minimalist look with maximum view.
and thermally. Does steel need a thermal break too?
Generally, no. Steel naturally has a lower coefficient of heat transfer than aluminum. It's less conductive. So steel frames usually don't require a thermal break to perform well thermally. That's a significant advantage in both simplicity and performance.
How are they made and finished?
Sections are typically welded together for strength. They're usually galvanized, coated with zinc for corrosion resistance, or bonderized, a chemical pretreatment for paint adhesion, and then primed for painting. You can also get factory finishes like baked acrylic enamel, urethane, or even PVC coatings.
Lastly, wooden windows. The traditional choice, known for warmth and insulation.
Their biggest natural advantage is thermal performance. Wood is a much better insulator than aluminum or steel, so wood frames are inherently more energy efficient, reducing heat transfer without needing added thermal breaks.
What kind of wood and how do they protect it?
Usually kiln-dried, clear, straight-grain wood for stability. It's factory-treated with water-repellent preservatives to resist rot and insects.
But maintenance was always the issue, right? Painting, staining.
Historically, yes, but modern wood windows have largely solved that. Most are now clad on the exterior.
Clad, meaning covered.
Exactly. The exterior surfaces are covered with a durable, low-maintenance material like vinyl, PVC, or aluminum with a tough factory finish. This protects the wood from weather, eliminates the need for exterior painting, but you still get the warmth and beauty of real wood on the inside.
Best of both worlds, then.
Pretty much. You get the thermal benefits and interior aesthetics of wood with the low maintenance of vinyl or aluminum on the outside.
Wow. Okay, we have really journeyed through this world of doors and windows today. Things we barely notice, revealed as incredibly complex, vital pieces of engineering and design.
It's true. From basic access and privacy to security, climate control, shaping the look and feel of a building, they're doing so much work, mostly silently.
So here's the thought to leave you with. Next time you walk through a doorway or gaze out a window, maybe pause for just a second. Will you see them differently now?
Will you notice that subtle hum of the door closer? The way the hinges are set? The way a window frames that view just so? Or how the light falls?
Consider how these elements, all meticulously designed, are quietly shaping your experience, defining the comfort, the safety, the very character of the spaces around you.
They're more than just openings. They're integral communicating components of the buildings we inhabit.
So stay curious. Look for these details in your world. You might find a whole new appreciation for the thoughtful design hidden in plain sight. Thanks for joining us on this deep dive.